to be different. What is the empirical formula? Of a compound containing carbon, hydrogen, and oxygen. So this time the fuel has 3 elements, not just 2. When combustion of 1.23 grams of the compound produces 1.80 grams of carbon dioxide and 0.740 grams of H2O. First thing you need to do to help you organize your thoughts is to write out that little combustion equation. What does it always look like? Fuel plus, keep going, plus oxygen yields carbon dioxide and water. Okay? Write your numbers in. What goes under fuel? What number? Okay, yeah, you can do that too. Okay, 1.23 grams is the fuel. And Christian, what you were telling me is what elements are in the fuel? C, H, and O. Those are commas, not ones. C, H, and O. Obviously, the 1.80 grams is the CO2, and the 0.740 grams is the water. Okay? Now, this fuel, when I burn it, all the C is converted to what? Carbon dioxide. So just like the previous one, what are we going to get out of the carbon dioxide? The carbon. Okay? This fuel, all the H is converted to what? To water. So what are we going to get out of that H2O number? The hydrogen. Now, you cannot get the O. See, this fuel has CH and O. You can't get the O from either of these numbers. Why not? Because the whole time this has been burning, what have we been pumping into it? We've been adding oxygen to it. So you can't get the amount of oxygen out of the CO2 or the water because all the oxygen doesn't come from the fuel. Some of the oxygen is coming what we've added to it. So you can do the carbon from the CO2 just like we did before. You can do the hydrogen from the CO2 just like we did before. But do that part, and then I'll show you how to get the oxygen. Okay? Okay, so the 1.8, I'm going to start writing on the board. I'm going to have to switch slides. The 1.80 grams, that's the CO2. That's a 0. The first thing I do is convert to moles of CO2. A mole of CO2 is 44.01 grams of CO2. And based on the formula for carbon dioxide, I know that there's a mole of carbon in every mole of CO2. Punch that in your calculator, and you get 0.0409 moles of carbon. Any questions on that? Okay. Doing the other one, for the water, we've got 0.740 grams of water. The first thing I do is convert to moles of water. A mole of water is 18.02 grams of water. And again, based on the formula, I know there's 2 moles of H in each mole of H2O. And when I punch that in my calculator, I get 0.0821 moles of hydrogen. Do y'all see that those steps are the same as the ones we did before? Those are still on the board. Okay, it's the same thing every time. Yes. Okay, 0.74 divided by 18.02 times 2. Okay, that's it. There you go. Yeah. Y'all getting it? Okay. In order to figure out what a formula is, empirical, molecular, whatever, you always have to figure out how many moles of each element you have. Now, what 3 elements are in this fuel? Carbon, hydrogen, and oxygen. You've got the moles of carbon. You've got the moles of hydrogen. Y'all, what we're going to do is we're going to get to moles of each one, and then we're going to divide by the smallest. Same thing we were doing last week. But we have to get to moles of oxygen. And that's different on this problem than the one we worked previously. So, going back to our information, we had 1.23 grams of the fuel. We now know how many moles of carbon were in that fuel, don't we? We also know how many moles of hydrogen were in that fuel. If we know the fuel was 1.23 grams, does it make sense to you guys that if we can subtract out the grams of carbon and the grams of hydrogen, we'll know how much of that 1.23 was oxygen? Okay? Do we have grams of carbon? We don't have that right now. What do we know about the carbon? We know moles. But if you know moles, do you know how to get grams from that? I see a head shaking yes. How do you go from moles to grams? Do you know what a mole of carbon would weigh? Carbon. You're doing hydrogen. Yeah, wouldn't a mole of carbon weigh 12.01 grams? So, I'm writing on the board, 1 mole of carbon weighs 12.01 grams. So if I say 12.01 times 0.0409 moles, that'll tell me how many grams that is. How many grams of carbon do y'all get? Yeah, that's what I got, 0.491. .491, yeah? Okay, y'all are probably still on the same page, but I got to go back to my other slide. So I'm going to go back to my other slide, and where I have grams of carbon, see I've got a blank in front of it. I'm going to write 0.491. Okay. Where do I get the grams of hydrogen from? Use this number? Can y'all set that up to go to grams of hydrogen? 1.01 grams of hydrogen is equal to a mole of hydrogen. So if I take 0.0821 and multiply it by 1.01, that'll tell me how many grams of hydrogen I have. What do y'all get for grams of hydrogen? .0829 grams of hydrogen. You got what now?
Like .0828, and I was rounding it, so
Did you say .0821 times 1.01?
I did the full, like...
Okay, that's fine. That's fine. Okay, what do I do with that number, that .082 whatever? Where do I put that number? Yes, I go back to my fuel, which was total 1.23. I've got the carbon to subtract out, the .491. Now I also subtract out the hydrogen, which is .0829 grams. So now I can figure out how much of that fuel was oxygen. So calculate that. Just subtract them. What do you get? 0.6561. .656 grams of O. Are we all together? We're all to that point? Go ahead, Myron.
Let me get my question again.
Okay. Okay. Now, let me keep talking because we're not ready to finish it yet. If we're trying to figure out the formula that's a C and an H and an O, I told y'all we have to figure out moles of each element. We got to figure out the moles of C. Have we done that? Yes. We've got to figure out the moles of H. Have we done that? Yes. We've also got to figure out the moles of O. We have not done that. What do we know about the O? We know that it's 0.656 grams of O. How do you get that to moles of O?
Divide it by 16.
Yes, you divide it by 16. Where does that come from? Periodic table, because we know that 1 mole of O is 16 grams of O. So what do y'all get for the moles of the O? 0.0, yeah, 410 moles of O. Does everybody get that? 0.0410 moles of O. Okay, so look, the red squigglies have our moles of each element underlined. Once you get moles of each of your elements in your formula, what's your last step? Same thing we were doing last week, same thing we did in the previous problem. Divide by the smallest. Which of those three numbers is the smallest number? Carbon, 0.0409. So everything gets divided by 0.0409. What's 0.0409 divided by 0.0409? 1. There's 1 carbon. What's 0.0821 divided by 0.0409? 2. There's 2 hydrogens. What's 0.0410 divided by 0.0409? 1. There's 1 oxygen. What is the empirical formula? CH2O.